Welcome to another Screencastify video where we're going to be looking more into our polynomial functions. So tonight we're going to look at what the types of roots that we can have. So in our last video, we realized that we could have real roots where the graph crosses the x-intercept or the x-axis, and we can have roots that do not cross and they are then imaginary. So the first graphs that we looked at were parabolas. Right now, let's just review our cubics. So if I have 3 real roots, that means I have to cross 3 times. It was possible to have 2 real roots if I had a graph that looked like this. So here I have, in the first graph, we have 3 distinct x-intercepts, which then means we have 3 distinct real roots. The second graph is different because here we have a double root. So we technically have 2 real roots, one that is distinct, and then 2 that are the same because they are double roots. So what happens then when I have a cubic that only crosses once? Well, if it only crosses once, that means we have 1 real root, and then we have 2 imaginary roots. And what we'll see when we go and look at the algebra behind this, that imaginary roots always come in pairs. One way that you could look at this, and this isn't really mathematically what's happening, but imagine that this x-axis was shifted up where I have the dotted lines, and you could see that it does have 3 answers. So obviously that's not really what happens, but that's how we can decide how many roots there are. So here we have the 1 real root, we have 1 imaginary root, or 2 rather, and because we have the 2 imaginary roots and the 1 real root, we have 3 roots total because it's a cubic. So how does that change if we're going to look at a quartic? So we haven't looked at a quartic yet, and I'm not going to do all the possible combinations, but let's look at a couple of them. So imagine we cross with our W 4 different times. We would have 4 distinct real roots. Is there any way that we could only have 3? So could we maybe, let's think here, if we do a double, and then we come back down. So here's our double root. Here are 2 distinct roots. So we have a double root. We have 2 distinct real roots. And then if we add that together, we do get 3 real roots. So I'm going to do one last. Could we get 2? So let's think about this. What if we had 2 double roots? So if we have 2 double roots, like we do here, we could end up with 2 real roots. So I'm going to leave it up to you to see if you could get 1 or see if you can get 0.